to share your opinion, your ideas, so we can make good progress on this document. Thanks. Any other things to be discussed before we go on to the next presentation? No? Okay, thank you, Ben. Next up, all right, is, so to be, just want to share with you, in my presentation mode, I don't have the record button. I don't see the record button, but Tim, yeah?
Yeah. So I found it. Apologies, we're not experts at this technology stuff.
So excuses to the working group. So the presentation of Ben has not been recorded from via WebEx. Excuses. So, but from now on, all the audio is being recorded.
Yeah. So apologies, Ben. So and Mark is up next.
Next is let's. Okay, I open the next presentation. Is Rolf?
Right, thank you. Can you hear me?
Yeah, I hear you clear. And do you? I will close the other one. Do you see the slides up?
I see the slides. Yep.
Excellent. Thank you.
All right. So this is about the Q&A minimization BIS, which we brought back to life. Expired last year, but we made a new revision. We, in this case, is myself, Stefan Bortsmeier, and Paul Hoffman. Next slide, please. All right. So this is a recap of Q&A minimization as described in RFC 7816. So at a resolver, when we get a request from a stub or from whoever, when we don't have the answer in cache, we will have to send queries upstream. Without Q&A minimization, the queries we will send upstream are just for the Q type and the Q name we get in the query. And with Q&A minimization enabled, we will send out a query with the Q name just one label more than what we know the server is authoritative for, and we hide the Q type by using the NS Q type for the outgoing queries. Next slide, please. So we now have the BIS, which has a goal to go from experimental to standard track and to describe the workarounds that are needed to really make this work. So we'll use the experience we gained while implementing Q&A minimization and write it down in this new version. Next slide, please. Right, so this is data from some measurements we've done, which shows that from the resolvers we are able to test using the RIPE Atlas platform that 47% of the resolvers already have Q&A minimization enabled. So this, even though this platform may or may not be somewhat biased, it shows that there is quite a lot of uptake of Q&A minimization. So I think it also is valid to move this to standard track. Next slide, please. So these are the changes we made since we brought this document back to life. So what we've done, we changed the algorithm a bit to include references to RFC 8020, so there's nothing below NX domain RFC. We made it more clear that you can, in some cases, use cached answers to prove that there's no delegation, so limit some outgoing queries. We added some text to make clear that there is a special use case to get the DS because you need to get it at the parent. We updated the examples in the document to make them a bit easier to understand. We started the effort of documenting the exact ways of how the different resolvers did implement this and which workarounds or other interesting solutions they used. So I already added this for Unbound, and I am reaching out to other implementers in order to get this information. So it's not finalized yet, but we're working on that. And then two things I would like to go into in more detail, which are the proposal to relax the Q-type recommendation and some text that we added about the increased number of outgoing queries. I don't see my slides anymore. I'm not sure if that's just me. And they're back. Yes, this one. Yeah, we can go to the next slide. Thank you. Okay, so as I showed just before in the diagram, the RFC, the 7816 recommends using the NSQ type when sending out the queries. And the assumption here, I think, is that because you want to get a delegation, you ask for a NS record. However, because the NS record or the server you're querying to is not authoritative for the data, you will get a delegation. So the text talks about you can also use other Q types like the AQ type and then prepend the Q name with the extra label to also get a delegation. But that really is not needed, because in the end, it doesn't matter for which Q type you send a query to the authoritative server, because it's not authoritative for it anyway, you will get a delegation. So you could as well just use other Q types. And that is also what we added to the draft. We relaxed, or we removed the recommendation to use the NSQ type, and we say you can use any Q type you want, as long as it's a data type, or you can, a data type or R type, so no meta types, and the authority needs to lie below the zone cut, so you can't use a DS type or things like that. Next slide, please. So it's still fine and allowed to use the NSQ type, but this also makes it possible to use, for example, the AQ type, and that does give some benefits. For example, it's not blocked at middle boxes as much as the NSQ type. We did find some cases that gave us issues when using the NSQ type. You won't have it if you use the AQ type. It's arguably privacy-wise somewhat better, because you now do not see anymore that you're doing QNAME minimization, because previously nobody was sending queries with the NSQ type, and now you suddenly see them appearing. You don't have it if you use the AQ type. And in some cases, you reduce the number of outgoing queries a little bit when the most used incoming Q type is the same as the Q type you use for QNAME minimization, because you don't need the extra query anymore to check if there is a delegation somewhere. So this is also what we do for Unbound. We use the AQ type for a long time already, and that works very well for us. So that's also the reason why we changed this in the draft. Next slide, please. So 7816 already mentioned that the number of outgoing queries can be increased when you have a query name with a lot of labels, but it only spoke about this in a context of performance. Your performance might go down a bit because you send out more queries. But what it did not cover is that you can also actively abuse this in DOS attacks. So if you, for example, as attacker, send a query with a lot of labels, and you make sure that's answered by a wildcard record, then you can trigger a resolver in sending a lot of queries outgoing. And if you then randomize one of the labels, you basically have the random subdomain attack, but then like 100 times bigger. So there's some text added to the document to describe this. The text we have there now says that resolvers supporting QNAME minimization should implement a mechanism to limit the number of outgoing queries. Maybe we should have or should use some capitalized should or must there. I'm not sure yet, but input from the working group is welcome there. Next slide, please. So I'm sure there are a lot of ways in which you can limit the number of outgoing queries. So one of the ways is described in the draft. That's the way that how it's done for unbound. So what we do is we limit the number of QNAME minimization iterations by a certain number, and then divide the labels by this number. And we make an exception for the first, in our case, 4 queries, because we expect that there are the delegations are for just a small number of labels higher up in the DNS hierarchy, so you have more privacy gain there. And next slide, please. Yeah, this is one thing we would like to add to the draft and would like input from the working group from is what to do when you are forwarding your queries. Does it make sense to do QNAME minimization at all there? Because in the end, the full QNAME will end up at the forwarder anyway. So maybe just describing that you don't need to do QNAME minimization in this case is enough, but it's something that we would like to cover in the draft. And with that, I am interested in hearing opinions.
Thank you, Rolf. Any questions? Yeah, I see. Let's see, what are the new ones? I think, Rolf, oh, it's jumping ahead. I think the first one is Rolf Weber. Please.
Yep. Yeah, hello. Yeah, some comments on the stuff. Overall, I think the limitation has to be something that has to be done. Should is okay. I don't think we should recommend such kind of complex mechanisms. Some people might want to do them, especially if you are in a setup where there's lots of reverse delegation, but others could just implement more simple stuff. So forwarding, it just doesn't make sense to minimize when forwarding, because as you said, the query will end up on the other end anyway, and you're just kind of using resources that are not used anymore. Because ideally, when you forward, you know who you forward to, and hope that that server also does minimization.
All right, thank you, Ralph. About the mechanism to limit, my goal here was to describe a way in which you can do it, but not necessarily make this the way to do so. But thanks for the input.
Yeah, that's okay.
Okay, thank you. Next is Jim Reed on the queue.
Thanks, guys. My question is about this limiting number of queries. We may want to put some lines in the document, Ralph, that speaks to specific cases where the resolver has got some kind of a priori knowledge about nested domain names or a string or a query name that's got large numbers of labels on it. I'm not just thinking about things like reverse IPv6 addresses, but maybe things like OIDs or possibly enum delegations. So say, for example, take the case of enum, you might have some kind of idea about what the national telephone numbering plan is. So therefore you could perhaps split up the queries based on a number of labels that reflect, say, an area code. Now, maybe that's a specific example, and maybe not to get that specific detail, but maybe some language around that might be something that would be helpful as another instance of how to limit the number of queries rather than doing it purely label by label or setting specific cutoffs on the number of labels by the number of iterations. Just a thought.
Right, thank you. Just to be clear, I think the limitation should always happen, not only for queries that are probably having a lot of labels, but indeed we might be able to use some logic to decide where to do the cutting. Yes, thank you.
Okay, thanks. Next in queue is Paul Vixie. Oh no, sorry, Stefan Bortsma.
Yeah, regarding the issue of the number of requests per query, like many things in QNAME minimization, it's not necessary for interoperability. It can be a unilateral decision. So in that case, the goal of the rule limiting the number of outgoing requests is to protect the resolver, but it does not have consequences for interoperability. Sorry. So I think that should is reasonable in that case.
Okay, thank you.
Okay. Next is Paul Vixie in queue.
Thank you. I have two observations. The first is that there is an authority misconfiguration that will be difficult to detect and probably deserves to be mentioned as a cautionary note. And that is where you have a mixed mode authority and the delegation has disappeared. So it is possible that you will receive an answer rather than a delegation. And if the Q type is NS, then the answer will be in the answer section rather than the authority section, but you will still receive an answer. And I know of buggy mixed mode servers that will return AA equal 1 on the first cache miss that causes the full the mixed mode recursive to fetch that. So there is a case where if you use the NS record type, you can receive a useless response. And in that case, you should be watching for it. But it's better, in my opinion, to recommend against the use of an NS record in order to eliminate this ambiguity in the misconfigurations that can occur. My second observation, if you want to take that.
Sorry, continue.
My second
no, that's an interesting observation. Thank you.
Is that while the rate limiting that's been mentioned certainly has a valid context in protecting the full resolver where this logic is being implemented, it also has implications in DDoS amplification. So we've already seen with random subdomain attacks that it's possible to for an attacker to do less work than the intermediary in terms of delivering unwanted traffic towards some victim. This is a new way to do that. If you imagine a deep random subdomain, you could end up causing a lot of traffic to be sent to an authority. And there isn't a great answer for the rate limiting, because if you decide in some cases that you don't have enough rate limit quota available to fully minimize a query, then that becomes a mode switch that your attacker has to turn off one of your privacy features. So I think we should recommend that some kind of rate limit be done, even if it ultimately means that in some cases the stub has to retry because the quota has been filled and the full resolver lacks the quota necessary to make more minimized queries. Thank you.
Right, so your proposal is to not limit the number of outgoing queries by having more multiple labels per query, but have a rate limit instead and just don't give an answer to the stub, thereby triggering them to retry, right?
That is the simple answer. I would hope that the document would be written in such a way as to encourage other interoperable, smarter, less simple answers. But that is the thing that comes to mind as how you would avoid this particular problem.
Okay, thank you.
Okay, thank you. Next in queue is Joe Adley.
So my comment is also to do with the choice of Q type. So I think the document assumes that all queue types are equal in the sense that they all get treated the same way on the authority server. So we have one example right now where that's not true, and I take responsibility for a partial. Oliver can have some of the blame for any. I realize any was already a little bit different anyway. But I think there's a risk that if you specify that any queue type is possible for this, then you are installing assumptions about all queue types and their behavior on the authority server, which might make it difficult in the future to install some tactical defense against some new attack that concerns just one queue type. I think it might be better to actually specify just one. So if we were going to choose one queue type, then we already have one queue type that's special in the sense that it's guaranteed to exist in any zone. And it's also, for example, appears in negative responses, which is SOA. I think SOA might avoid Paul's concern about NS records. I think it might be simpler to specify just one. And SOA, I think, is unremarkable because everyone has to implement SOA. So maybe just doing the opposite of what you're doing, instead of trying to free this up and make it easier to implement whatever kind of query you want in a minimized query to an upstream authority server, specify exactly that it has to be SOA. And that might make things simpler and shouldn't really affect security at all.
I'm not sure what's the benefit of using SOA over NS is in that case.
Well, for example, I just referred to the comment that Paul just made, that NS in particular might have some baggage.
Right, okay, check. Yeah, so the point of not allowing all of them because some of them might turn out to be special, that might be valid. So maybe is it an idea to select a small set of types you can choose from and then still have the let the implementer decide?
Seems possible. I think it's worth considering, is there a benefit to having a small set? For example, a benefit to privacy over specifying just one. And if there's no benefit to privacy, maybe simplicity is the best answer.
Yeah, fair enough. Thank you.
This is Paul. I'd like to follow up.
Sorry, Paul, did you have some comments?
Yeah, I wanted to say that I agree with Joe, but I would like SOA to be in the set of things that are permitted, simply because it would, if a full resolver implementer has a good use to make of those SOA records in terms of perhaps delegation revalidation, then I would like SOA to be an available choice so that they can serve two purposes with one round trip. Thank you.
Yeah, noted.
Thank you. Next in queue is Mark Andrews.
Yeah, in terms of the forwarder, setting minimized queries to the forwarder actually forces a forwarder that doesn't do QNAME minimization to QNAME minimize it for itself. We shouldn't assume, nothing here should assume that the upstreams are doing the right thing on your behalf. We have to trust forwarders to a certain extent, knowing they will get the full QNAME, but we don't have to trust the TLDs, the root, everybody else in terms of getting the full QNAME.
Right, so in that case, it's not against the machine you're forwarding to not to see it, but the queries they are going to send out are then minimized.
Yeah, you can force, a stub resolver can force any recursive server to do QNAME minimization on its behalf just by talking to the recursive server, the same with QNAME minimized, with a QNAME minimized series of queries. The same applies through a forwarder.
Right, interesting idea. Yeah, thank you. I'll try to write a bit about that for the draft.
Okay, thank you. Eric, we withdraw his question. I think next one, last is Warren in the queue.
So can someone remind me why we're not just using the original queue type? It seems if you do that, then you're not going to require an extra query at the very end to figure out the actual answer. I'm guessing the thing is you potentially lose some privacy that way. I don't really know if it's a big privacy leak to mention that you're looking up an MX or an A or a quad A or what.
Well, actually, I don't think you're losing privacy. So the thing is that if you get a query for the A and you use A as to hide the queue type, then that's basically the same, getting the original query and the query where you're hiding it, right?
Yep.
So if you pick the queue type that is most common on the incoming one, then you don't leak any extra information, but you still have somewhat less queries you're sending out.
Yeah, I think if you just use whatever the original queue type was, it should save you an extra query. And I'd really like to see this get deployed, but performance is also important to some folk. So if we make it as performant as possible, hopefully we can get this deployed wider and faster.
Right.
Yeah. So, Benno, chair head off. Question to Ralph. Mm-hmm. So in Unbound through QNAME randomization, we also switched from querying NS records to A for different reasons, actually. So that's also the current implementation in Unbound, or?
Yeah. So the reason we switched from NS to A is because we found out that NS queries are blocked sometimes, and A queries are not. That's the reason why we switched. And then turns out there are some added benefits of overusing A over NS, and that it doesn't really matter for the QNAME minimization case. As in, you get the delegation whether you send a query or whether you send an NS query.
Thanks. Oh, okay. Eric, last question in the queue. Please go ahead.
One other rationale for possibly using the client's query is for this A versus quad A distinction, is that there are plenty of IPv6 only networks where quad A is the dominant query type coming from them, and A is going to actually stick out more. And if you're looking at it from a performance perspective, doing the quad A first or using the query type the client asks, like the quad A, is going to be more performant there, because otherwise, if you just do the A lookup, then you're going to have to wait. Then you're going to have to take a miss until that quad A lookup then goes through.
Good point. Thank you.
Okay, thank you all. So one of the actions for the working group chairs was, is it with the edits and the feedback, is it ready to go working group last call? There's a question also to the authors, of course, but that's is it possible for the next month working on the document and make progress, to make sufficient progress to have a working group last call somewhere in 4 weeks, 6 weeks, 8 weeks?
Yeah, so I'll have to incorporate what I now heard from the working group into the document, and then we can slowly work towards that. Yeah, but I'm planning on continuing on this on a short term.
Okay. Thank you. Any other comments, feedback? No? Thank you. Thank you all. Then next up is avoid fragmentation from Fujiwara-san. I will share preview. Okay. Okay. Do you all see the slides?
Yes.
Okay, excellent. Please go.
Hello. I'm Kazunori Fujiwara, JPRS. Paul Bixby and I submitted draft Fujiwara DNSOP avoid fragmentation 03. Fragmentation avoidance in DNS. And I missed a summary slide This draft proposes to avoid IP fragmentation in DNS. It proposes to set IP don't flag option to UDP, DNS UDP response reply packet, limit to EDN0 DNS UDP response size, and encourage small response size. And these page shows changes from 01 to 03. We changed the title as Fragmentation Avoidance in DNS and referred draft IETF interior flag fragile. And fixed minimum MT for IP version 4 is 68, only 68. And we added DNS flag day 2020 proposed 1232 as an EDN0 buffer size. And we added minimal response configuration. And the consideration of DNS packet size and how to measure pass MTU and calculate the maximum DNS UDP payload size. Next slide, please. And how to measure and calculate the maximum DNS UDP payload size. In order to measure pass MTU, use Linux tool trace path. On resolvers, measure pass MTU to well-known authoritative servers. For example, a2m.root servers.net or a2m.gtld servers.net. On authoritative servers, measure pass MTU to resolver addresses. Before measurement, correct resolver addresses or public resolver addresses. If the reported pass MTU is, for example, no smaller than 1460, the maximum DNS UDP payload size would be 1432 for IP version 4, which is 1460 minus IP version 1 header size 20 minus UDP header size 8. And maximum DNS UDP payload size for IP version 6 may be 1420 for IP version 6, which is 1416 minus IP version header size minus UDP header size. Next slide, please. Is the draft useful? And please consider adoption. And we may need definition of minimal responses. That's all. Please comment.
Okay, thank you. Any questions? Any comments? Mute myself. So the question to the room is for adoption. So if you think it's useful, please speak up. Is it work for the working group? Joe, please go ahead.
Hi there, it's Joe Apley here. I think this is useful because I think we have a serious problem with fragmentation in the DNS, and I think it makes sense to write something about it. I think some of the things in this document I'm either misunderstanding or I think might need some more thought. It seems to propose something that resembles a path MTU discovery in the sending of responses. But I think in practice, for example, an authority server that sends a response that is too big and then needs to resend because it was dropped somewhere, whether or not it gets an ICMP message back indicating that it was dropped because it was too big, I think there's no state held there to allow a retransmit to happen. So that's probably just something to take away and think about on the list. But I do think the general topic is worth describing.
Thank you, Joe. Tim, do you have a question?
Yeah, sorry, speaking as a chair, I believe this is one of the drafts that we were going to send out a call for adoption on and really look for people saying positive things, much like Joe said, like, yes, this is useful and here's why, let's work on this. And so while we'll sense the room, I believe this will be one of those that you'll see an email about this, and we hope to get some positive, some feedback from folks on whether to go up or down. So, so that was the only comment I had from the chair side.
Thanks. Oh, sorry, one moment. Next one is Rolf Weber.
Yeah, I also think the draft is useful and we should adopt it. With regards to Joe, my reading of the draft was that a lot of the discussion is what do you set as an initial UDP size when you send out packets, and then of course if you don't receive anything back, you have to do something, probably switch to TCP. I don't think it was part MPU discovery that was suggested.
Fujiwara-san, do you want to comment on that? Okay. Paul, you have maybe a comment or a question? Please go ahead. Paul Pixie.
There is not an intent in the current text to design path MTU discovery. It is meant to allow someone to do that if they want to know what the end-to-end minimum MTU would be, but it also just recommends some defaults that can be determined pretty much knowing only your own local MTU without any discovery process. I've made no secret. I believe that we will need one area path MTU discovery, and so I may want to use in my own future work the flexibility that's being deliberately put into this draft to permit the MTU to be discovered. So there's nothing in this draft which intends to demand that it be discovered. Thank you.
Okay, thank you. If there are no other comments or feedback, then I want to wrap up this presentation. So do expect a call for adoption in the next weeks on the mailing list. Send positive feedback, at least be interactive and contribute if you think this should be working group, a draft document. Thank you. Then I want to go on to the next presenter. Let's see, that's Paul Wouters with the PowerBind presentation draft.
Yeah, people can hear me?
I do hear you, yes.
Okay, great.
See the right slides? Yep.
Yep. Okay, so we were supposed to have a little bit more discussion on PowerBind on the list, but the world has moved in very strange ways, so that didn't really happen yet. So I'll do a very quick overview, and then I'll see where we're at. So next slide. So the problem this is solving is actually not a technical problem; it's a political problem. Some people just don't want to trust the high-level keys. They want to do DNSSEC transparency, or they want to be able to sort of try to force those keys to be more open in their delegation-only status, where they don't try to take over their own child domains. And this is specifically important for the root and the TLDs, where the big powerful keys are that people don't want to trust, or at least trust in a minimum way, and then verify that they're actually good parents. So next slide. So the solution is to add one bit that would mark a zone as delegation only. So it would only have NS records and glue, and it wouldn't try to define anything else. It wouldn't go across a zone cut or any dot in the domain name. So again, this would be for the root or TLDs mostly. In this example, we can see that the tld.org will set this bit, saying that they will only delegate and not deep link. And then, for instance, the domain IETF.org will not set this bit, so it can have any data under it that it wants, like data tracker or www, any other thing. So next slide. Sorry, it's a little hard to read. But because it's encoded as a DNS key flag, what it means is that this is actually encoded in both the key ID tag, but also in the DS output itself. So if a child sets this flag and gives a DS to the parent, then the parent will publish this, and this DS record will be completely different. So if at some point someone wants to undo this, either the child or the parent maliciously, then this would be visible in the DS flag. And so also this means that if you have specific out of bound DS records configured for your enterprise, that would also be visible here. So it gives an additional layer of protection against abuse by the parent key. And so even if the child's entire zone would get replaced, because the DS lives at the parent, there would still be evidence at the higher level zone. Next slide. So again, the benefits are a public commitment by the parent to not screw around with their child zone. The other reason this is really important is because this allows us to do DNSSEC transparency. So if a TLD would implement this, then we can already start monitoring all the DS records and DNS key records for the zones of that parent, that we know that when they change or not. And so this would already give us additional CT-like transparency for DNSSEC, which without this flag we cannot do, because we would basically have to log all the DNS data, which is of course impossible. Next slide. So does adding a new DNS key flag break anything? It shouldn't. We tested this back in 2018 with the then main resolvers that were out there. I hacked some code to set up basically a reserved flag and to set it and see if any implementation would fail. Everything worked fine, so I think we're good. But we could also ask Jeff Houston to do more testing. Next slide. And a quick overview of the changes since I first introduced this a couple of years ago. Wes became a co-author, so the English language usage got improved a lot. We clarified that if you set the bit that you also expect not to be skipped, because your parent could still, in theory, skip you entirely. But there's an expectation that if you will not skip your children, that your parent will also not skip you. I'd already talked about DNSSEC transparency, that it's very useful. We suggest that the root key is already treated like this, so it doesn't need this flag, but the code internally would treat it just like if it's been set already, because the root zone is supposed to be a delegation-only zone. We added an exception for underscore labels, because those really are not zone cuts. They really refer to the zone itself, and it would be really annoying if we would have to define zone cuts and DNS keys for each underscore label that we want to introduce. So that would require some special handling in the resolvers. And we added a bunch of operational considerations. We discussed migration from and to, and more clearly described the problem of signed glue data. Usually what happens at a TLD level, if there's glue and that belongs to a domain and that domain is then deleted, then that orphan glue is sort of adopted by the TLD to make sure that other zones using that glue wouldn't die. But then if you enable this bit, then of course that would be malicious deep signing and it would get dropped. So we explained that a little bit better. And then next slide. Yeah, I kind of mentioned it, like, so go to the next slide actually. So what are the disadvantages of using this? One problem is that you cannot have empty non-terminals. So you would have to make a delegation for that. I'm not sure how big of a problem that would be for some zones. The other thing is that if you are using your name server records in your own zone, so let's say .ca would use this and they would have like ns1.ca and ns2.ca, then that would be problematic. So you would actually have to create a special subzone that would not be marked with this bit so that you could put your name servers in there. I did a quick check, and most TLDs already do this, so I don't think this is a big problem. It used to be that it was all contained within one zone, but it seems operational rollouts these days all use some sort of dedicated zone for it, like they use a subzone something dash servers or DNSOP or something like that. Second level domains that usually have their NS records as part of their zone are not a problem because they tend to not set this. So for instance, noheads.ca would not set this because I'm not delegating any authority to subzones underneath me. So there's no reason for me to set this bit, and I can put whatever I want in my zone as I currently have it. Already talked about orphan glue. It doesn't protect the zone Apex data itself from abuse, but usually that's not a problem because there's no cryptographic material. So next slide. And then it's next step. So far, I tried to start this discussion once, and only Joe Abley replied with an email that was more on the political side, as in saying, "Why do we need this bit? It's really naive if you don't trust ICANN on this setup." And while I agree with Joe, this is specifically targeting those people that do not agree with us, that think that there should be more transparency, more auditing on those keys. So I would like some more technical discussion. Did we overlook something? If you would roll this out or not. And then once we have this, I think people like DKG and me are really interested in starting building some DNSSEC transparency tools to actually use this. So that's it. Any questions?
Thank you, Paul. Yes, there are some questions going from top. I think, yeah, Ben Schwartz was the first one in queue. Please go ahead, Ben.
Hi, this is Ben Schwartz. I'm very excited about DNSSEC transparency. I think I understand why we need zones to publish a commitment to be delegation only. I don't understand why that commitment has to be machine readable. That is, why do we need this flag in the DS record? Why can't we just have the zones put up a document on their webpage that says we promise to be delegation only?
So how would you implement that into the resolver? The whole point of having this bit is that you actually publicly commit to it, and that you cannot briefly pull back on that commitment, send out some sneaky DNS data to a target, and then enable your regular deployment again.
But I think that this draft doesn't defend against that attack either, because I can equally well rescind this flag for one target. I can serve a non-flagged version of the DS.
But the transparency part of that would be that we can easily log if you change that bit. So if my client supports this, I can see that you're briefly giving me a customized answer that's just for me.
Right, but a transparency would equally allow us to see a non-delegation record in your zone.
But I mean, I'm not sure how you would scale all these like a resolver needs to have code to try and enforce this as much as possible. So maybe send a question to the list and I can answer better there.
Okay, thank you.
Okay, thank you. Next in queue is Peter van Dijk.
Hello, this is Peter van Dijk from PowerDNS. Can you go to slide 8, please?
Yeah, there it is.
You say no changes required for the authoritative server. Servers like bind check zone contents on loads. They might want to learn about this so they can avoid loading zones that would violate this constraint.
Sure, everybody can add more code. This is more saying that there's no processing logic that changes that are required. So there's no migration process from current to future.
Okay, that's right. Can you go to slide 9, please? Does not protect child Apex data. Why not? I skimmed the draft and I don't see why it would not protect child Apex data.
that's not behind a doc. It's not behind a delegation. So if the parent adds something for that, it doesn't traverse the dot into the child zone.
No, but it still wouldn't be a delegation one dot away. It would be authoritative data one dot away, which the flag prohibits, unless I'm missing something.
I think we're talking about the different zones versus the parent versus the child.
Okay. Yeah.
So it's about. So if let's say if CA sets this bit, then nohats.ca is protected from being taken over by CA by direct signing from CA. But any data it would put in as glue, maybe maybe you're actually right. Maybe IPsec key would get protected. A and quad A doesn't get protected because there's always parental glue, right? So they would follow the unsigned glue to wherever that leads. But that's not a big issue because you would validate any cryptographic material of like resulting data like TLSA records or something downstream.
Yes. Okay. Thank you. No further questions.
Thank you, Peter. Next in queue is Ralph Weber.
Yeah, so as usual, the poor resolver has to do all the hard work. So as you can imagine, I don't like that very much. And you're looking for a technical solution to a political problem, and I don't think that this is actually something that will work for a couple of reasons. So we have TLDs out there that actually serve authoritative data. I know that, like DNIC did allow customers to pay a premium to have data in the DE zone, and there's .tel that only gives out sort of authoritative data. So I don't think that it's actually applicable, and it's as Ben said, it's a political problem. Let them deal politically with it, and don't put more stuff on an already complex DNSSEC validation process.
So you're welcome, of course, not to set it bit. So if DE thinks that its current model isn't compatible with that bit, then it could decide not to offer this extra protection to its customers, right? And or to fold as many customers into their own zone as possible. It is very much an outlier compared to the majority of TLDs, though.
But still, the poor resolver or validator has to implement it, right?
Right.
Okay. Thank you. Next in queue is Joe Abley.
Hi there. Hi, Paul. It's Joe Abley here. So I'm not simply going to repeat the. Well, I am going to repeat actually. I'm going to repeat my apparently non-technical comment. I think to add complexity to the system, and in particular adding complexity to the validator. I know you said it on slide 8 that extra work required by the validator was small, but I don't know that that's true. I think that's a eye of the beholder sort of thing. I think in order for it be worth adding this extra complexity, there has to be a problem to solve. And it seems like the problem that you're trying to solve is the problem that the TLD or a root server operator might go rogue in a way that was otherwise difficult to detect.
No. Okay. Let me clarify this a bit more.
Okay.
We think that those chances are pretty low because we know all these people involved in running the root and the TLDs. There's a large subset that is very loud outside of our community that considers this as like a deal-breaking thing to ever trust DNSSEC. That is the argument I'm trying to remove.
It's the same.
Sorry, carry on.
The same reason for, this is Wes, sorry, the co-author. One of the same reasons that people want DNSSEC transparency is because they don't trust people to use DNSSEC properly, because they don't trust the ability for things like, a parent not to just arbitrarily insert records, on behalf of the child and take them over. There's various public companies that have actually said that they would never do DNSSEC at IETF microphones specifically because of that. They don't trust their parent. They have other issues in my mind. But
well, okay. I mean, all right. So I'll set aside the question. I do think there are a lot of protections around that. I think business models of everybody who runs a significant TLD depend on following contracts which, when it comes down to it, for many TLDs is their only significant asset and their only reason for being in business. So I think there's a lot of pressure outside the wire protocol that already ought to be fairly convincing, and people who are not convinced by that are unlikely to be convinced by anything. However, there is one point I wanted to make that is less layer 9, which is that I suspect, I can say from my own perspective, my own knowledge, there is at least one legacy TLD that contains records from a long time ago that don't necessarily fit an elegant schema. So I suspect this is probably true with every TLD of any significant age. So an example is orphan blue. We have records that remain in the zone that don't correspond to registry data in the way that you might expect and can't be suppressed because there are dependencies, for example, to other domains. I think there is the potential for operational fallout from anybody who decided that every TLD zone of millions of records was completely clean, and there was never an example of a response where you do get an RSIG. It is a record or a response that is signed and properly lives in the bailiwick of the TLD zone, but is also required for other delegations to work. If the world is not as clean as it might seem by just reading the RFCs. So I think my summary is still the same though, that I think this adds a lot of operational and implementation complexity, and it's not obvious to me that it's going to provide any convincing protections that are going to be better than the ones we already have in the form of policy and contracts.
Okay, thank you. Paul, want to answer or go to the next question?
The next question.
Next question. Next question from, let's see, there was some editing, some questions, Joe. Next is Warren Kumari, please.
Thank you, Warren Kumari. So I'm feeling dumb because I don't really see how this provides any real protection. I mean, I can see that it prevents a parent from just answering with a different A record directly, and this would say this is delegation only. But what I don't see is why wouldn't a parent just answer with a different delegation and different DS, and now they can accomplish the exact same set of badness or attacks.
Sure.
Right? This stops in doing a delegation one. But
so exactly. But once they change the delegation, they have to change the DS record for that child.
only to one client, right? If I'm trying to poison.
Yeah, sure. So that's why. But we can monitor that with the DNSSEC transparency. So once a TLD enables this bit, we can then easily log all the DS changes and all the DNS key changes, and then report them back. So we would basically catch this parent similar to CT transparency.
I don't think that that's true. There's nothing that says that the parent can't answer with targeted answers for whoever they're trying to poison this name towards.
They would also have to change the DS record that they signed for the child, because if they publicly have a DS record that says we will not do this, they would not only have to change the child delegation, but also their own DS record to the root, saying that they would actually not do this delegation only thing.
No, they wouldn't, right? For nohets.ca, you gave CA a set of NS, and you gave them something so that they have a DS. Why wouldn't CA, if they wanted to poison nohets.ca towards me, why wouldn't they just hand me a different set of NS records pointing at servers they control and publish a different DS for that name specifically towards me?
So you then know for sure that your DS record has changed, right? Like previously, what could happen was that no DS record or DNS key would be changed because the CA zone would just deeply sign nohets.ca records.
Yes.
Require any other changes.
So if I may, with in order to implement DNSSEC transparency, when you dive into the details, and there was many discussions a couple of IETFs ago about this, you end up having to log every signed record that a parent might have. In order to catch a fake A record or a fake quad A that's 3 levels down in the tree but issued by a parent, right? The parent can sign anything it wants. It can do that. You end up having to log everything. With this bit, you only need to log DS records with certificate transparency in order to catch these types of problems, because you trust that the resolver is actually checking that that no other stuff was being allowed. So it changes the implementation burden on DNSSEC transparency quite a bit.
I mean, that also requires the parent, who you believe might be malicious, to actually be publishing all of the DS records and all resolvers to be checking them.
That's what transparency protocols do. They check that is happening.
Okay.
Yes. Okay. Good. Last question in queue, Matthijs. We bumped you, but you still have time. We still have time. You're not muted, but I don't hear anything. Okay. Okay, sorry. Then we go to the next presentation. Matthijs, if you can, yeah. Matthijs will ask the question on the list, on the mailing list. Thank you, Matthijs. Next presentation is Tim April. Oh. Okay. Hi, Tim.
You able to hear me?
Yeah, excellent.
All right.
You see the slides?
Yep.
Yep, excellent. Thank you. Please go ahead.
I'm Tim April from Akamai. Next slide, please.
Oh, there we go.
I just realized as I was reviewing it to get ready to talk about it that I didn't include the goals of this draft in here. This started out of a bunch of conversations about how could we support secure transport between a resolver and an authority, or even a stub that's doing full resolving for the client, and trying to find how to communicate with another machine over which protocols it supports. So the communication establishment between non-cooperating machines. So this draft proposes 2 new RR types, and I'll go over why there are 2 in a second. For now, I've just been calling them NS2 and NS2T, and it builds off of the SVCB draft that Ben was talking about earlier. And these names, these new RR types, the way it's written now, allow the existing NS records to coexist with NS2 and NS2T to allow for resolvers that don't support these new records to continue operating as normal. Next slide, please. The first RR type is the NS2 record. This exists similarly to how NS exists, where it's at zone cups, where if you see it if you get a delegation, or if you get a response with that is a delegation and it has the NS2 record in it, that's acting very similarly to the NS record. It may be present both in the child and the parent, similarly with the NS record. And then what it does add is it uses, as with the SVCB draft, there's the service form, which can have a whole bunch of parameters about how to connect to another machine. And then there's an alias form, very similar to a name or CNAME, where in the parent you can say, or if you're dealing with a registry, you can add the service form, the alias form, to your DNS service provider and only have to add one record, and then the service provider can take it from there. So the registrant doesn't have to manage all of their NS set and change that whenever the service provider wants to update it. Next slide, please. Examples make this a lot easier. At the bottom of the record, the response, you can see the existing NS record and the glue records that go along with it. And then there's 3 examples of an NS2 record in this is the service form, where you can have a list of different prioritized list of different name servers, where you can select which transports are supported. If you want to provide a DNS fingerprint, rather than using the PKI, you can use PIN certificates. And then there's also other parameters defined in the document that allow for alternate parameters around each of the different protocols that are currently being discussed. So like the DO URI template exists in there. And there's no, like in this example, it doesn't specify that the delegated server name, so in the 3rd example down where it says ns3.example.com, that doesn't have to match the host that's in the URI template. Next slide. And then here's an example of the alias form, where if you're using a DNS provider for your zone, you can put in, or if you're, in this case, if you're using multiple providers, you can just add the alias form that points at the other 2 DNS providers, and they can return the NS2T records, which I'll talk about in a second, for for that zone, and allowing them to be more agile of how they change their records if they need to move a customer around or things like that. Next slide. And then, so this is the NS2T in the draft that's being called NS2 target, where this is a record that doesn't exist as a zone cut, where if you're that provider that's just been alias to, you can say, you can return these NS2T records, which can be either a service form or an alias form. There is a concern about loops coming up with if you reuse the alias form. There's rough text in there about how to prevent or how to detect loops. That still needs to be thought about a little bit more. And so this can be referred to by either the NS2 or the NS2T record. And it has exactly the same format. It's just a different RR type to indicate that it's not a zone cut. So if you want to serve other records below that part of the zone. And then there's an example on the next slide. So very similar to as it was before. I think the only thing that changed here is that there's one less record, and it's an NS2T record type for each of these labels. And then next slide, please. In the draft, I've expanded on the existing service parameter keys that were defined in the SVCBE draft. While I was coming up with this, I was trying to reduce the number of queries that have to go to the authority at the same time. This does bring up the concern of the record size ballooning out of control. Still trying to find which way to go with that. But the current thinking I had while I was working on it was that ideally if the parent supports an encrypted transport over TCP, or so if you're doing DNS over TLS or DNS over HTTPS, you can do larger packets more easily. So the larger response size may not be as much of a problem. Where the keys you can see the keys that have been defined here so far. I'm sure there are more that we could add, and would be interested in feedback from the group, the working group on that. And then next slide. So this draft was initially written before I went on leave in November, and haven't been following terribly closely with the DNSSVCB updates. And then once I got back to work, the world was in a different place. So I need to realign with all of that work. And then there are a few placeholder sections that need more work. And I have some feedback from people that I've passed the draft to before publishing it on Data Tracker that I need to incorporate back in. And then I think the last slide. And then I'm very interested in anyone that's willing to review, has questions, comments, ideas of if this is a terrible idea and we shouldn't go forward with it. And if there's any interest in bringing this into the working group, or what I should revise before we reconsider that.
Thank you, Tim. We have a number of people in the queue. First one is Sam Weiler. Please go ahead.
Hi, Tim. Sam Weiler. Just to make sure I'm clear, it looks like the NS2 record is designed to appear at either the child or the parent or both, with no restriction there. Is that right?
Yes, that's how I was going back and forth about that. And
so you should be aware that having a new record type that appears only at the parent is a can of worms that you do not want. Go look up DS grandparent problem. And if you're not convinced that this is a can of worms you don't want, ask us again.
And I was expecting that it wasn't going to be in both places. It would mostly be in the child only because of lack of support at the parent during rollout.
It's actually more complicated than that. It involves resolvers out in the world and breaking them.
Yeah, okay.
They expect that when they ask the child for a record, the child has it and doesn't give a referral to the parent. But all the logic around label stripping and DS processing rules is all about dealing with this.
Okay.
Okay, thank you. Next one in queue is Matt Pouncett.
Hi, yeah, I was going to say, I guess this is related to what Sam, but that I think if we're trying to look at redesigning NS, one of the things that should be included in that is getting rid of the parent-child ambiguity that we currently have with NS, where it seems to be a little bit unclear which one is actually meant to be trusted and in what situations. There's a whole lot of extra processing in there right now that could probably be fixed by taking that into account and making sure that there is no ambiguity about whether the delegation or the parent name server set are equivalent or not. Plus including the ability, if they were separated out, that the NS set at the or replacement for the NS set at the parent could be signed, for example, if there was no ambiguity about who's authoritative for that data. It seems to me like a lot more needs to be thought about if we're going to try and redesign how NS works.
Okay. Thank you, Matt. Next one in queue is Joe Abley.
Joe Abley. My question is related to the first two, I think, which is that it's not clear to me, and maybe I missed something in the draft, is to how a resolver finds these records at the time when it needs to know them. So, for example, it's not obvious whether if records are provided in a parent zone, whether they are going to be returned as part of a referral. If they are, then we have response size considerations, but maybe that's protocol dependent. But if they're not returned as part of a referral, then the client really only either has to probe or it has to do DNS over UDP 53 or TCP 53 in order to find out something, at which point it's already using the old transport, and we're eliminating the possibility that a cold resolver could start using modern transports and avoid things like fragmentation problems. So I think I'm interested in how this might work if it was rolled out in a way that would allow clients that were capable of never using the old protocols if they decided because of local policy or some reason that they didn't want to. It's not obvious how that happens right now.
Okay, thank you. Peter van Dijk.
Hello, Peter van Dijk, Power DNS. I agree with everything that Sam, Matt, and Joe have said. Besides that, I have read the draft, and as a resolver implementer, this scares me. There's so much complexity here, so many interactions that could cause a resolver to do extra work on behalf of a client, potentials for loops, etc. That besides the things that have been said that suggest this might not be deployable at all, will lead me to not support this draft in this form.
Thank you, Peter. Next, Alexander Dupree.
Yes, hi, thanks. I also wanted to sort of second a lot of the comments. I do think, though, the point in particular about referral responses is key, that, you know, if there is some way of doing this, it's important that it be present in some way in the parent, ideally signed, although I recognize the complications of that, and present at least, you know, in authority or additional section, you know, as some kind of glue from the parent and the referrals.
Okay, thank you. Last is Paul Hoffman. Welcome, Paul. Please go ahead.
So this is, and all the questions that just came before, is related surprisingly to work that's going to be done in the ADD working group. Not that ADD is dealing with authoritatives, but a stub resolver talking to a recursive resolver has a relationship very similar to a recursive resolver talking to an authoritative one. So there's the question of discovery, the question of hints, the question of how long do we remember authoritative answers and such like that. So it may be that if this working group doesn't take this on immediately, that it could come later as, I guess the polite way for me of saying this is, I think the ADD working group is about to grind over all of these topics yet again, but on, yeah, at least in a working group sense, and with hopefully a draft coming out soon on this. And maybe lessons can be learned from that that would apply for this use case, which is similar, namely, I want to upgrade from port 53 to something more secure.
Sorry, thank you, Paul. Okay, I'm just consulting with my timekeeper. Do we still have for the last question from Ralph and Ben, or should we close? Did we close the queue? We didn't close the queue yet. So Ralph and Ben, can you ask a short question or comment?
Well, it's more comment. So I think the difference between ADD, because stop to resolver is quite different from resolver to authoritative, where we already have sort of the whole protocol suite laid out, how to do delegation. And one of the things that, I mean, some people pointed out is that the bootstrapping is a problem. If you put NS2 required to be in the parent, then of course the deployment is a real mess, and there's probably something gained by keeping it in sort of the ambiguous form we have currently, where it's in the parent and the child, and with the sort of, but allow more flexibility in the rollout. So I think that's one of the motivations why the current draft is as it is. If we want to tackle the, here's how we do a full reamp, I agree it requires more work, but it also requires a lot of more time in the rollout. So that's the options we have.
Thanks. Ben. Ben Schwartz, last question, comment.
Ben Schwartz, I just want to comment that some kind of solution to this problem is, in my view, effectively blocking the deprive working group from accomplishing what's listed in their new charter, which is now focused on recursive to authoritative encryption. So I don't know about this particular proposal, which is certainly tricky. I don't claim to totally understand it, but we need some kind of solution here.
Okay. Thank you, Ben. There's a good suggestion. So I think the chairs of the ADD, DNSOP, and DPRIVE have to sit together and discuss where the work should, take place. And given Tim, thank you for your presentation. I think there's sufficient feedback for another iteration and discussion with the people just on the mic and the mailing probably on the mailing list, how to make a next iteration and how to fit it with other activities in the DPRIVE, ADD, and DNSOP working group. Are there any other things people want to mention here? Okay, I think we're fine. I forgot to mention one last thing from the previous presentation, Paul Wouters, in the PowerBind draft. So one of the actions was a call for adoption or not. So there was quite a lot of discussion. Please go on the mailing list, and we will want to go forward at least with the process. So we will ask call for adoption. We will send out a call for adoption to the mailing list. Paul has presented this draft a couple of times, has been discussed for 2 years. So the working group has to make a decision here. Okay, that being said, that was kind of the summary of the previous presentation. Any comments on that? No? Good. So then we go to the last presentation of this afternoon. Thank you, Tim. The Fujiwara-san draft call for adoption has just been sent to the mailing list. I will go to the last presentation of this afternoon. It's by Willem Torop.
Yes.
There we go.
Can you hear me?
I do hear you very good. And do you see the slides?
I can.
Excellent. Good.
So this is about an initiative that emerged from a meeting with some open source DNS software vendors and affiliates last summer at the IETF 105 in Montreal. Next slide, please. So I work at NLNet Labs, and at NLNet Labs we develop, amongst other things, open source DNS software. And at conferences, we meet with DNS operators that use our software, and we learn from their experience. We discuss how we can improve on things, and those operators use not only our software, but also other open source DNS software. And they do this for robustness, because other software has hopefully different bugs. So also, the other open source DNS software vendors discuss or meet with all the operators at conferences. And one of the recurring themes during our discussions with operators is that it would be nice if there would be a cross-implementation standard way of configuring all the different DNS software. Not super urgent, they have a solution in place, something based on Ansible or Salt, but still. Next slide, please. So one of those operators is Affilias, and they always tell us that they really want us to cooperate with the other open source DNS vendors to address the things we discuss in a cross-implementation, compatible, and preferably standardized way. So at some point they thought, instead of having all those individual meetings with the different vendors and asking them to cooperate, why don't we have a meeting with all of them together? And so they organized the DNS Summit on the Friday preceding the IETF 105 in Montreal, with NLNet Labs IC and CZNIC. And one of the topics was standard configuration and provisioning management. Next slide. So we discussed it and we came up with two candidates: catalog zones, which is a convenient provision mechanism for existing DNS software, because the configuration is in a normal DNS zone. The dissemination of configuration is via zone transfers. Also, implementations exist and there's already an internet draft for it. The other interesting candidates is the network configuration protocol and Yang. NetConf is successor of SNMP and sees a lot of activity and development at the IETF. Unfortunately, it's a complete new infrastructure for DNS, but CZNIC and PowerDNS are currently working on implementing it. PowerDNS, someone from PowerDNS told me that they have a working test setup. Additional advantage from NetConf Yang is that it gives you feedback on the things you configure. Unfortunately, there's no describing how this works. CZNIC and PowerDNS develop their own solution, though, you know, I'm sure they exchange experiences. Next slide, please. So we decided at that meeting that the easiest thing for cross-implementation solution was to all make catalog zones work and interoperable. But so it exists a draft, but it did not have actual configuration properties defined in the draft. So Peter from CZNIC had a nice idea to come up with a minimal set of configuration properties for zone provisioning and then make a formal definition for it. Next slide, please. In Yang, and create an internet draft for that. Then the catalog zone draft could reference that draft for the zone properties that should be configured in catalog zones and provide some sort of translation from Yang to catalog zone format. So in slide is the actual sketch we did of the minimal set of properties on the flip over that day. And so those are basically the things needed to describe primary and secondary relationships. Next slide, please. So we discussed the ID more at IETF 106. And then in the beginning of February, I was at FOSDEM 2020 and I saw a presentation from Leo van der Woestijnen. Who is a DNS operator using multiple DNS softwares from multiple vendors. And he presented on how he would like to use catalog zones to provision his infrastructure and how it didn't quite work yet, but almost. And there and then we had representatives of all the vendors. And yeah, we started the initiative to move along with our IDs. And so with the support from of Andre, we picked up from the existing expired catalog zone draft, which before had only IC authors, and arranged a group of people from the different vendors and Leo as operator that want to pick up the editor pen on this draft and turn it into a cross-implementation supported standard. Next slide, please. So catalog zones is a method for automatic DNS zone provisioning by storing and transferring the catalog of zones to be provisioned as one or more regular DNS zones. Next slide, please. So it's simply a list of zones listed in the catalog zone as so-called member zones. On the slide is an example showing what that looks like. They are enumerated with uniquely valued labels in a zone section in the catalog zone as pointer records. The picture shows a primary and its relationships with secondary. So the catalog zone is distributed along these relationships, and from the catalog zone, the secondaries learn that they should serve example.com, example.net, and example.org in this specific example. Next slide, please. But there could also be multiple catalog zones for different secondaries. Next slide, please. Primary for a catalog zone also does not necessarily have to be the same primary that is the primary for the catalog zone itself. Next slide, please. And furthermore, there could be, it's very flexible. That's what I want to share here. There could be a catalog zone for other catalog zones, helping in more complex zone provisioning management. Next slide, please. So today I posted a new version of the draft with all the things that we have discussed so far with the new editors. And one of the things we decided is to leave out zone properties or configuration items as sketched on the flip over sheet altogether. To us, the most important to configure properties seems to be which zones go where in your authoritative DNS form. Also, several future primary-secondary relationships can be set up in advance, and those sets of configuration can be associated with catalog zones. Provisioning it differently would just mean moving a zone from one catalog to another. Next slide, please. The other thing that we changed in the existing draft is that zones need to lose all associated state on an authoritative when its unique ID changes. There's a need to erase all state, for example, if the owner of a domain name changes, the owner that pays for the zone, it should not inherit all the metadata from the previous owner, or DNSSEC state with online signing, authoritative. And simply removing and adding a zone is unreliable because a secondary might be down or miss the notify message. Next slide, please. Yeah, this is an ID from Leo. So if zones would be enumerable, then you could make external from the DNS software module that would interpret catalog zone and modify the different DNS software with different adapters. Next slide, please. So I think this would be good work for the DNSOP list to take this up, and so we could discuss and develop this further on. Next slide, please. Then the other part of our ID, zone provisioning definitions in Yang. So Yang is a data modeling language for the network configuration protocol, the successor to SNMP, so to say. One of the nice things about Yang models is that IENA maintains a registry for IETF Yang models. So I just created quickly a draft of a draft, so to say, of this ID and submitted that. A data model for configuring DNS zone provisioning. Next slide, please. These are the authors from the different vendors cooperating on this. I'm really happy to have Peter on this, who is doing the netconf Yang implementation for PowerDNS. And also Ladislav is the authority on Yang, I think, so that's really great too. So the current draft is really just a sketch. There are many things wrong with it. We need to discuss this properly with the experts that we now have on board. Next slide, please. One of the things that we are discussing is that the existing Yang definitions in the IENA registry could use some improvement. The domain name is not perfect, especially not with it. it allows for escaped characters, but then it does not count those escapes in the 63 byte label lengths, for example. There are many issues with it. So next slide, please. So with this draft, we would like to review and work on an initial model amongst the others first. And after that, if the question to you is DNSOP interested in seeing these kind of drafts providing formalized elements of DNS in Yang? So that's the presentation. And I'm open for questions now or remarks.
Well, I was waiting for the chair to acknowledge me, but since I didn't say I was going to be with you.
So go ahead, Wes. I can do it too.
The only thing I wanted to point out is that, this is a very old topic in the IETF with many failed attempts. So it would certainly be good, for one to actually succeed. And there was a draft in the past with the Yang model in it too. So you might go search for that. I don't remember the name of it. And there was an SNMP MIB long before that. But the one positive thing that actually did get published was RFC 6168. I'm the author of that, but it was really, I was just the pen. There was probably 25-ish people in a DCOMA working group that, working group that is, that tried to codify what would it actually take if something was going to be successful. What are all the requirements of a management model? And I would definitely go look at that and see if you're fitting all those holes and which ones are not. Transferring zones was one of the big ones that was listed in there. And ironically, it was actually started in a Vancouver meeting room long ago, so the timing is perfect.
Okay, interesting. I'll do that. 6168?
Yes, that's correct. 6168.
I'll have a look. Thanks.
Thank you. Yeah, I was speaking, but I was muted, so sorry for that. Thank you, Wes. Next in queue is Paul Vixie.
I want to indicate support here. I did something like this called meta zones about 15 years ago, which was not really meant to be a candidate for standardization and needed a bigger team, larger perspective, more formal model. We now have those things, and I will be very happy to abandon my meta zone configurations in favor of this once you guys get it done. So thank you.
Okay, thanks.
Okay. Thank you. Any other questions, comments? Okay. Thank you. So, Willem.
Yes.
These two drafts are there. It's so one set. They're combined to some extent. So, how do you think you want to proceed? Both drafts hand in hand?
No, I think what I would like to happen now is that the catalog zone draft would get adopted. I will send it to the announcement to the list and see if there's enough interest in it. And for the other draft, the zone provisioning definitions in Yang, we still need to work on that, but I want to know if this would be interesting for the DNSOP working group to look at or to process, so to say.
Okay, thank you. Yeah. Good, thank you. Any other comments, questions to Willem? Okay, then we'll proceed. So we will send out not today, but later this week or next week you want to kind of face the different call for adoptions. But we will go to the mailing list for the catalog zone for call for adoption. And this draft will be the last draft about the young model, the DNS zone provisioning. We'll see another iteration and will be presented next IETF or when work has been done. Any other things to be mentioned at the end of the working group meeting? A little bit over time, but still a lot of participants. Okay, so just after this meeting, I will send, or the chairs will send a doodle poll to the mailing list to select a time slot for the next working group meeting. It's on Thursday, April 23rd, but we haven't selected a time slot yet. So please fill in as soon as possible, and we want to close the time slot, the doodle, Thursday, end of business day. Any other things I should mention? Some administrative work? No?
I think we're good. I want to thank everybody as well. So,
thank you.
Good discussion.
Thank you for your feedback, discussion, your time. Good. Thank you. Thanks, everyone. See you in 1.5 weeks on Thursday, 23rd. In the doodle poll. Thank you.